Good evening, everyone. Welcome to Tech Tutorials 2K21. So today's our topic is transitive closure. So now we are finding transitive closure by Warshall's algorithm. So using a dynamic programming approach. Using dynamic programming approach. So transitive closure will say like when you take a directed graph. So now we are trying to find an edge from one vertex to another vertex. So if there exists a vertex directly or indirectly. Like suppose for example if you have a vertex from A to B and then from B to C, then definitely you have an edge from A to C, right? So now we are using this Warshall's algorithm. We are trying to find the transitive closure of a given directed graph. So this is an algorithm. So this algorithm will take an adjacency matrix as an input. So now we are implementing your Warshall's algorithm for computing the transitive closure. So that is of our algorithm purpose. And here we are taking adjacency matrix A of a diagram with n vertices as our input. And the expected output is the transitive closure of the diagram. So now initially the rank of 0 is nothing but the adjacency matrix. So which adjacency matrix is formed by your graph, that is said to be a rank of 0. So now we can take three loops. So k, I and j will run from 1 to n. So it will start from the first vertex to continue until the n vertices it will reach. So here what we are trying to do, so we are finding whether we have a directed path that can exist in between I and j. Here I and j are two different nodes. So we are finding whether there is a direct path is existed or there is any indirected path is existed between that particular nodes. So now we'll go through an example. So this is an example directed graph. So here this is only the directed graph. There is no weights here. So simply if you have a path between two nodes, simply you can make that particular I and j position with 1 or else the remaining positions with zeros. So here see from A to A there is no path, it will taken as 0. From A to B we have a path, it taken as 1. From A to C, we didn't have a path 0. So A to D, we didn't have a path 0. So now we are finding here from B to D, we have a path. So B to D is 1 and all the remaining are zeros. So whereas for C, there is no outgoing edges from C. So that is from C to A or C to B or C to C or C to D, we didn't have any paths. So simply we make all the paths are zeros. And then from D to A we have a path, so it will be 1, and from D to C we have a path, it will be. So this is an adjacency matrix. So first of all you have to form an adjacency matrix. So that is of your rank 0. So simply you can take R of 0. R of 0 is nothing but an adjacency matrix. So simply you can take A, B, C, D. So here also A, B, C, D, and my values are 0, 1, 0, 0, and then 0, 0, 0, 1, all zeros, and 1, 0, 1, 1. So now what we are trying to find, now we are finding there is any path existed between two nodes, right? So for that here we are using Warshall's algorithm. So the first one, rank of 0, is nothing but it must reflect the existence of a path with no intermediate vertices. That is, R of 0 is just the adjacency matrix. So now what we are trying to do is we have to make the vertices as like an intermediate. Then we are trying to find if there exists any path between the nodes. So here from this rank 0, I am trying to find the rank 1. Rank 1 I am trying to find. So now this rank 1, it can be generated from rank 0. Right? So now see here. So A is common, right? So you have to take A row and A column as usual. Then we start for finding there is any path is existed. See now from B to B. So here we are checking from B to B. There is any path from A. Right? So I can now we are finding whether we have a path from B to B with A as an intermediate. So now here I am finding there is no path. So with B to A with A as an intermediate. So simply I can make it as 0 itself. And then from B to C, so this is B to C. So I didn't have any path with A. So simply I make it as 0. And then from B to D I have a direct path. So you can simply take, if you have a direct path, no need to find there is any indirect path or not. So simply you can keep all your ones as usual. So from C to B, if I am trying to find a path, there is no path directly. So I am trying to find with A as an intermediate. So with A as an intermediate, I cannot move from C to B. With A as an intermediate, I cannot move from C to C. With A as an intermediate, I cannot move to C to D. So simply all zeros. So now from D to B, so if I reach from A as an intermediate, yes, I can reach from D to B with A as an intermediate. So simply you can make this value as 1. So from D to D, if I reach with A as an intermediate, no. So I cannot reach D to D with only A as an intermediate. So simply this value is 0. Okay. So now what this rank 1 will say, it once reflect the existence of path with an intermediate vertices number not higher than 1. So that is just vertex A is box, row and column are used for getting rank of 1. Okay. So now by using this rank of 1, we are trying to find rank of 2. Right. So now you can use this matrix for finding rank of 2. So now R of 2. So here I can make AB as an intermediate. Right? AB as intermediate. So we all know this can be formed as A as an intermediate. Right? So when I take A as an intermediate, I'll find this particular matrix. So now I'm making AB as an intermediate here for finding rank of 2. So here we can keep common B row and B column. So now it is 1, 0, 1. Right? And you can keep all ones wherever we have ones, you just keep it as ones itself because already there is a path. So now 1 and 1. So okay. So now we are trying to find whether we can reach A to A with AB as an intermediate. So this is A. So now I'm making AB as an intermediate. I can reach to A? No. From A to C, right? A to C. If I reach from B, no, I can't reach. So this is also 0. From A to D, can I reach with B? Yes. I can reach from uh, A to D with B as an intermediate. See here, B as an intermediate, I can reach from A to D. Simply I can make this value as 1. So now for C to A. So here I can't reach directly. By making AB as an intermediate also I cannot reach. So simply I can take it is also 0. From C to C I cannot. From C to D I can't with A and B. So simply I can take this is also 0. So now can I move from D to D with AB as an intermediate? Yes, I can. So I can come from D to D with A, B as an intermediate. So I'll simply make this value as 1. So how I get this? This is simply I'm making AB as intermediate. So this matrix will get when we make AB as an intermediate. So rank 2 is nothing but it will say that like we cannot take more than 2. Right? So more than 2 as consideration. So now I need to find R of 3. So for this I have to make C as also included as an intermediate. So this will form by AB as an intermediate. So from this I'll make C as an intermediate to find rank of 3. So now A, B, C, D, A, B, C, D. So here I can keep my column and row as common. So I'll take all the values which are ones. I'll make as usual. So like 1, 1, 1. Right. So now you have to find the remaining things like from A to A. So I can reach from A to A with ABC as an intermediate. See here, A to A is I can reach with ABC as an intermediate. No. So simply it is 0 only. Right? Because I can't reach. From B to A. So this is from B to A. Can I reach ABC as an intermediate? No. I can't reach. So from B to B, can I reach from B to B with A, B, C as an intermediate? No. I can't reach from B to B with A, B, C as an intermediate. Simply it is also taken as 0. Right? So now this is your output after you are making A, B, C as intermediate. Right? So now we need to find R of 4. So rank of 4. So here I need to make A, B, C, D as an intermediate. Right? A, B, C, D as an intermediate. So here A, B, C, D as intermediate. So here I can take D row and D column as an intermediate. Right? So here I make D row and D column as an intermediate. So I keep all these values as usual. So simply I can write 1, 1, 1, 1 and here it is 1, 1, 0. And all the remaining ones also I keep here like this. So now I'll try to find the remaining things from A to A. So can I reach from A to A with A, B, C, D as an intermediate? Yes, I can. See here from A to B and from B to D, I can reach to A again. So now A to A, I have a path with A, B, C, D as an intermediate. So now from A to C, can I reach A to C with A, B, C, D as an intermediate? Yes. See from A to B, from B to D, from D to C, I can reach. So by making B and D as an intermediate, I can reach A to C. So for that reason, I'll make this value is also 1. So B to A. Can I reach B to A, B, C, D as an intermediate? Yes. By making D as an intermediate, I can reach to A from B. So simply I can make it value also 1. So can I reach B to B with A, B, C, D as an intermediate? Yes. See here from B to D, D to A, from A to B. So I can reach from B to B with DA as an intermediate. So simply I can make this value as 1. So can I reach B to C with ABCD as an intermediate? Yes. I can reach with D as an intermediate. So simply I can make this value is also 1. So now finding, can I reach C to A with ABCD as an intermediate? No, I can't reach. See here, I cannot move from C to anywhere. So simply from C to A, the value is 0. So can I reach C to B? No. Can I reach C to C? No. So this is your final matrix. So now it will say this is your transitive closure. Right. So in this way we can find the transitive closure of a given directed graph by using Warshall's algorithm of an approach dynamic programming. Okay. Thank you.